China just broke the sound barrier of ground transportation. Their new maglev hit 620 miles per hour, faster than a Boeing 737 at cruising altitude. While the world debates electric cars, China built trains that make airplanes obsolete. The impossible just became real. Something extraordinary is happening in China that will forever change how humanity moves across the planet. Can you imagine traveling faster than a commercial airplane, but on land? China has achieved it. While some countries still use trains from the last century, China has created machines that seem straight out of science fiction. From trains that float completely in the air without touching tracks to mechanical beasts capable of breaking speed records that seemed impossible just years ago. Most people think trains are slow, heavy metal boxes rolling on metal tracks. China just shattered that idea completely. Their new maglev prototype hit 387 miles per hour in testing. The final version is designed for 620 miles per hour in vacuum tubes. To put this in perspective, a commercial airplane cruises at around 550 miles per hour. This train would be faster than flying. The technology works through magnetic levitation. Instead of wheels touching tracks, powerful magnets lift the entire train above the guideway. No friction means no speed limit from contact. The train floats in a controlled magnetic field, pushed forward by electromagnetic forces. It's like a bullet shot through a magnetic cannon, except the bullet is a passenger train carrying hundreds of people at speeds that defy belief. Number 8. The T-Flight maglev, breaking the airplane barrier. We start with something that has completely changed the rules of ground transportation. The Chinese T-Flight maglev reaching 1,000 kilometers per hour, a speed that makes a Boeing 737 during takeoff seem slow. To give you an idea, a commercial airplane flies at about 885 kilometers per hour. This train surpasses that speed on land. How is such speed possible? The key is that this train never touches the tracks. It floats completely in the air using powerful magnets that lift it above the guideway. By not touching anything, there's no friction to slow it down, allowing speeds impossible for traditional trains. But the real secret to achieving these extreme speeds lies in the vacuum tubes. While other trains constantly fight against wind resistance, the T-Flight travels inside tubes where there's almost no air. It's the same principle that allows spaceships to travel so fast in space. Without air to slow you down, you can reach incredible speeds. The result is striking. This train can cover the distance between Beijing and Shanghai in less than 2 hours. A journey that normally takes 4.5 hours on the world's fastest conventional trains. This speed is completely redefining what it means to travel on land. The technology nobody talks about. But here's what nobody's talking about. This technology might not even be Chinese. And the real story behind this machine could change how every country thinks about the future of travel. Maglev technology wasn't invented in China. It was developed in Germany in the 1960s. German engineers created the first working maglev systems. They built test tracks and prototype trains decades before China entered the game. The Transrapid system in Germany could reach 268 miles per hour back in the 1980s. German companies spent billions developing this technology. They had working systems while most countries were still using diesel trains from the 1950s. But Germany made a critical mistake. They never scaled up production. Political debates about cost and environmental concerns slowed development. The technology remained trapped in research facilities and short test tracks. So how did China end up with the world's fastest maglev? The answer involves technology transfer deals, joint ventures, and what some engineers call strategic acquisition of foreign expertise. In the early 2000s, China needed to upgrade its transportation system fast. They invited German companies to build maglev systems in China. The deal seemed simple. Germans would provide the technology. Chinese companies would handle construction. Both sides would benefit. Shanghai got the first commercial maglev line in 2004, built by German company Transrapid. It connected the airport to the city center, 19 miles completed in just 8 minutes at top speed. But technology transfer agreements have fine print. Chinese engineers worked alongside German experts. They learned the systems inside and out. They studied every component, every design principle, every manufacturing process. Within a few years, Chinese companies understood maglev technology as well as the Germans who invented it. Then, China did what China does best. They took that knowledge and improved it. Number 7. The CR450, China's domestically engineered speed demon. The CR450 is the machine that proved China doesn't need to copy anyone in railway technology anymore. This monster reaches 420 kilometers per hour in official tests, a speed that left engineers around the world speechless. Its aerodynamic design is inspired by fighter jets with an elongated nose that cuts through air like a sword. But what's truly remarkable about this train isn't its top speed, it's its endurance. It can maintain over 350 kilometers per hour for hundreds of kilometers without breakdowns or damage. The secret lies in its advanced cooling system that uses liquid air to keep engines at perfect temperature, even after hours of running at maximum power. What's most impressive is that it can be supplied with electricity while moving, completely eliminating the need for technical stops. This train can cover distances that in other countries require domestic flights, maintaining speeds that surpass many small aircraft. China created a practically unstoppable machine capable of traveling without rest for distances that other countries consider impossible for ground transportation. Why China is obsessed with speed. China's obsession with speed isn't about bragging rights. It's about economic survival. The country has 1.4 billion people spread across a massive territory. Moving people and goods efficiently isn't just convenient. It's essential for keeping the economy running. Traditional transportation creates bottlenecks. Highways get clogged. Airports reach capacity limits. Even China's impressive high-speed rail network, currently the world's largest, has constraints. China's current high-speed rail system covers over 25,000 miles. That's more than the rest of the world combined. But even these trains max out at around 217 miles per hour in regular service. For a country trying to connect cities separated by thousands of miles, that's still too slow. The economic math is simple. Time equals money. Every hour saved in transportation multiplies across millions of passengers. A businessman who can travel from Beijing to Guangzhou in 3 hours instead of 8 can close deals faster and generate more economic activity. Consider the economics. A maglev line between Beijing and Shanghai could move passengers in under 2 hours. The same trip takes 4.5 hours on China's fastest conventional high-speed train. Cut travel time in half, and you essentially double the economic productivity of both cities. Number 6. The CR380D, the Silent Dragon. The CR380D marked a before and after in Chinese railway history. This was the first train built completely with innovative Chinese technology. While previous models used German and Japanese technologies as a base, this monster is 100% Chinese design and engineering from scratch. Its most striking feature is something you'd never expect in a high-speed train. It's practically silent. While other trains sound like fighter jets, the CR380D passes like a ghost. You can stand next to the tracks and barely hear a whisper when it passes at over 350 kilometers per hour. Its dragon head design isn't just Chinese aesthetics. It's pure aerodynamic engineering applied to perfection. That elongated and curved nose cuts through air so efficiently that it eliminates practically all sound resistance. Chinese engineers achieved something that seemed impossible, combining extreme speed with total silence. This train showed the world that China no longer needed foreign masters. With speeds that compete with the world's best and a level of silence that surpasses them all, the CR380D announced the arrival of the golden age of Chinese railway engineering, the vacuum tube secret. The secret to reaching 620 miles per hour isn't just magnetic levitation, it's the vacuum tube system. Most maglev trains still fight air resistance. At high speeds, pushing through air becomes the biggest obstacle to going faster. Think about it this way. A car needs more fuel to go from 60 to 80 miles per hour than from 40 to 60 miles per hour. Air resistance increases exponentially with speed. At 300 miles per hour, air resistance becomes a brick wall. At 600 miles per hour, it's like trying to push through concrete. China's solution is elegant and ambitious. Put the entire maglev system inside a tube with reduced air pressure. Less air means less resistance. Less resistance means higher speeds with the same energy input. It's the same principle that makes space travel possible. Remove the atmosphere and you can go as fast as your propulsion system allows. The engineering challenges are enormous. These tubes need to be perfectly sealed across hundreds of miles. They require massive pumping systems to maintain low air pressure. Temperature changes cause expansion and contraction that could crack tubes or misalign tracks. The vacuum tube maglev represents a completely new category of transportation. It's faster than driving, more efficient than flying for medium distances, and more comfortable than either option. Passengers experience smooth acceleration without the turbulence of air travel or the vibrations of road transport. Number 5. Shinkansen E5, Japan's lesson in perfection. The Shinkansen E5 isn't just a train. It's a lesson in perfection applied to mass transportation. This legendary bullet train is Japan's fastest commercial train, reaching 320 kilometers per hour. But its true power isn't just speed. It's something no other railway system has managed to equal. Its punctuality is absolutely precise. The average delay is only 18 seconds per year. Think about that. Across millions of journeys, hundreds of millions of passengers, thousands of trains, the average delay is 18 seconds annually. It's perfectly designed to maintain exact schedules, with each component calculated to function like a Swiss watch on rails. Its automatic control system uses artificial intelligence to detect and prevent any problem before it happens. The maintenance is so meticulous that each piece is changed before showing the slightest sign of wear. The Japanese have achieved something that seemed impossible: 60 years of operation without a single fatal accident. But here's what's most impressive. The E5 uses a regenerative braking system so efficient that it produces more electricity than it consumes when going downhill. When other countries build fast trains, they're not just competing with Japanese speed, they're competing with 6 decades of indisputable perfection. The global response. Other countries are watching China's maglev development with a mixture of admiration and concern. If successful, this technology could give China a massive economic advantage. Fast, efficient transportation networks drive economic growth. Countries with better infrastructure attract more investment, create more jobs, and generate more wealth. The United States is taking notice. American companies are exploring their own vacuum tube transportation systems. Elon Musk's Hyperloop concept shares similarities with China's approach, though it uses different technology for levitation and propulsion. Several startups are working on competing systems, but most remain in early testing phases. The difference is scale and commitment. While American companies test small prototype systems, China is building full-scale infrastructure. They're not just proving the technology works, they're proving it can work at national scale. Europe is in a difficult position. German companies developed the original maglev technology, but they never built it at the scale China is attempting. European transportation infrastructure is advanced but fragmented across many countries with different standards and regulations. Japan has its own maglev program. Their L0 series system can reach 375 miles per hour and will connect Tokyo to Osaka by 2027. Japanese engineering is world-class and their safety standards are exceptional. But even Japan's impressive technology looks slow compared to China's 620 miles per hour target. Number 4. L0 Series Maglev, Japan's floating future. Japan has completely revolutionized rail transportation with its innovative L0 series maglev, capable of reaching an impressive 603 kilometers per hour and defying all laws of conventional ground transportation. Although not yet commercially operational, it's expected to enter service in 2027 and promises to change everything we know about traveling on land. This revolutionary train uses a superconducting magnetic levitation system that keeps it floating 10 centimeters above the tracks without touching absolutely anything. Its suspension technology is so sophisticated that it can maintain perfect stability even at speeds exceeding 600 kilometers per hour, something that seemed impossible until now. What's most striking is its ability to transform distances. It will connect Tokyo with Osaka in just 67 minutes, a journey that currently takes 2 hours and 15 minutes on the fastest Shinkansen. By floating completely, it eliminates friction and wear, allowing speeds that no wheeled train could achieve. The L0 series integrates the world's most demanding Japanese safety standards with record speeds. Its futuristic design and levitation capability are completely redefining expectations about speed and efficiency in future rail transportation. The economic calculation. Building vacuum tube maglev systems requires enormous upfront investment. Initial cost estimates for China's network run into hundreds of billions of dollars. The Shanghai maglev line cost approximately $1.2 billion for just 19 miles of track. That's roughly $60 million per mile. But China's government takes a different view. They see infrastructure spending as long-term economic investment. A maglev network that lasts 50 years and transforms transportation across the country justifies massive initial costs. The economic benefits compound over decades. Traditional cost-benefit analysis doesn't capture the full value of revolutionary infrastructure. When the interstate highway system was built in America, critics called it wasteful spending. Decades later, economists estimate it generated economic benefits worth trillions of dollars. China also benefits from scale economics. They're building multiple maglev lines simultaneously, spreading development costs across many projects. Manufacturing components in large quantities reduces per-unit costs. The government financing model makes ambitious projects possible that would be impossible under pure market economics. Number 3. Germany's ICE-3, engineered perfection. We reach third place with the German ICE-3, Europe's fastest train that maintains the reputation of the nation that invented magnetic levitation. This beast reaches 368 kilometers per hour in tests, though it operates commercially at 300 kilometers per hour for safety reasons. Its real secret isn't in pure speed, but in something revolutionary. It's practically impossible for it to derail. The ICE-3 uses distributed traction technology that allows it to accelerate and brake more efficiently than any worldwide competitor. Its active tilting system allows it to take curves at speeds that would instantly derail other trains, but it maintains perfect stability thanks to sensors that constantly monitor track conditions. German engineering took aerodynamics to obsessive levels. Every surface is mathematically optimized to reduce air resistance. Its wheels and chassis use special metals designed to resist extreme wear during decades of high-speed operation. The result is impressive. Germany built a machine of absolute precision that can run at extreme speeds for decades without failing, completely redefining what railway safety means. The challenges nobody mentions. Despite impressive progress, vacuum tube maglev technology faces significant challenges. Maintaining low air pressure across hundreds of miles of tube requires constant energy input. The vacuum pumps alone consume enormous amounts of electricity. Engineers estimate that maintaining partial vacuum could require the output of multiple power plants. Safety systems become more complex when trains travel at 620 miles per hour in sealed tubes. At 620 miles per hour, a train travels more than 900 feet per second. Traditional braking systems can't handle these speeds safely. Emergency stops from maximum speed could take several miles and generate dangerous heat levels. Weather impacts create additional complications. Temperature changes cause tube expansion and contraction. A temperature swing of 100 degrees could cause miles of tube to expand by several feet, enough to misalign the magnetic levitation system. Earthquake zones need special engineering to prevent track misalignment. Even small movements could cause the levitation system to fail. China's engineers are addressing these challenges through extensive testing and redundant safety systems. But every solution adds complexity and cost to the overall system. Number 2. Italo AGV, Italy's distributed power revolution. In second place, we have the Italian Italo AGV, a train that reaches 360 kilometers per hour and is changing rail transportation in Europe. This train connects major Italian cities, operating commercially at 300 kilometers per hour with an efficiency that impresses engineers across the continent. What makes the Italo unique is its design without traditional locomotives. Instead of having motors concentrated at the front, it distributes power throughout the entire train. This allows it to accelerate more quickly and better utilize interior space for passengers. Its construction uses ultra-light materials that significantly reduce total weight, which translates to lower energy consumption and higher speed. The advanced suspension system eliminates practically all vibrations, creating a smooth travel experience even at maximum speed. The Italo AGV demonstrates that the combination of intelligent aerodynamic design, advanced materials, and efficient power distribution can create an exceptionally fast and reliable transportation system. Who would have thought the Italians would create the continent's fastest private train? The global competition heats up. China's 620 miles per hour maglev represents more than transportation technology. It's a statement about technological leadership and economic ambition. The country that masters ultra-high-speed ground transportation could gain decisive advantages in the 21st century economy. Other nations are responding with their own ambitious projects. India announced plans for its own Hyperloop system connecting major cities. Saudi Arabia included Hyperloop connections in its futuristic city projects. Russia announced research into vacuum tube transportation systems connecting Moscow to distant regions. Even developing nations don't want to be left behind in this race. The implications extend beyond transportation. Vacuum tube technology has applications in cargo transport and industrial processes. Magnetic levitation could revolutionize manufacturing and energy storage. The innovations developed for 620 miles per hour trains will likely find uses in completely different industries. China understands these broader implications. They're not just building infrastructure, they're building the foundation for future dominance across multiple sectors. The maglev project is part of a larger strategy to lead the world in advanced technologies. Number 1. Alpha X, the train of the future. Meet the train of the future, the Shinkansen Alpha X, an experimental 10-car, 320-meter-long machine that is breaking all railway speed records. This technological beast reaches an impressive 400 kilometers per hour in tests and is completely revolutionizing what we believed possible on rails. The Alpha X uses extraordinary technology. It constantly analyzes more than 10,000 different data points while traveling, controlling everything from outside temperature to the smallest vibrations. Its most striking feature is its extremely long 22-meter nose, designed like the tip of a spear to pierce through air without resistance. What's revolutionary is that it can change its shape while moving. The train has sensors all over its surface that detect if there's strong wind or changes in air pressure and automatically adjust its position to maintain extreme speeds without losing stability. Its emergency braking system is equally impressive. It can completely stop the train from 400 kilometers per hour in just 2 minutes, surpassing all world safety standards. Although the Alpha X isn't yet commercially available, Japan promises it will enter service in 2030, establishing the new world standard for railway speed. Conclusion: the revolution is here. What we've just witnessed is the reality of ground transportation in 2025. From trains that fly over magnetic fields to machines that break speed barriers on land, we're witnessing a revolution that will forever change how we move around the planet. The question is no longer whether these trains will replace airplanes for medium distances, but how quickly it will happen and whether the rest of the world will be able to keep up with innovation happening at unprecedented scale in China. China understands this dynamic perfectly. They're not just building trains, they're building economic dominance. But there's something else happening that most people haven't noticed yet. Something that could make even a 620 miles per hour train look like old technology. And it's already being tested in a secret facility just outside Beijing. The future of transportation isn't coming. It's already here, levitating at 620 miles per hour through vacuum tubes across the most populous nation on Earth. Which of these trains impressed you the most? Would you dare to travel at 620 miles per hour on land? The race for the future of transportation has just begun, and China is leading it at speeds the world has never seen.